Hello friends, welcome in the next lecture of several variable calculus. In the previous lectures we discussed definition of function of two variable. After this what we discuss? Domain, range of the function of two variable. Then we discuss the graph of the function of two variable. Then we discuss the level curves. Today in this session we have to discuss all these things, but it is for the function of three variables. So our topic is, today's topic is function of three variable. Function of three variable. We define first this and then we will again convert it is into the n variable, function of a n variable. So what is the definition of function? Function is a rule that assign what? That assign each ordered pair in that function of two variable to the unique real number. Similarly here again each ordered triplet, what we can write? Function is a rule that assign each ordered triplet or each xyz into the real number. Okay, so what we can write? I think no need to write the definition, but just what we can write: a function f of three variable is a rule that assigns each order triplet let x, y, z in D subset of R cube, in D subset of R cube to the unique real number, to the unique real number denoted by f of x, y, z. F of x, y, z. Again it is the same definition, just order triplet we have to replace order pair by order triplet. Same definition. What is the example? Suppose you have to take temperature at any point on the surface. So what it is? Temperature T. What should be this? This depends on what? This depends on longitude, latitude and time. We can say at what time temperature you are taken. So what you can say, this is x, y and t. So there our temperature is the function of a three variable. Temperature is a function of three variable. Again, what is the definition of domain? It is the set of all points where the function is defined. Okay. What is the set? What is the range? Again same. What is range? It is the set of all images. It is the set of all images. So we take one example. Sketch the domain of the function f of x, y, z is ln of z minus y plus xy sin z. xy sin z. So what we take example? F of x, y, z is equal to ln of z minus y plus xy sin z. Okay, so we have to find the, what we have to find? Domain. So what is given? Again f of x, y, z. F of x, y, z is equal to ln z minus y plus xy sin z. Now tell me where the function is not defined. Is there any problem for xy? Is there any problem for sin z? Sin z can define everywhere. Here the problem is that what? In the ln. So ln of 0 and negative number not possible to find. Therefore function f of x, y, z is defined if z minus y is greater than 0, strictly greater than 0. That means what? Z is greater than y. That means what? Z is greater than y. So what we can say? Thus the domain is the space above the plane z is equal to y, is the space above the plane z is equal to y. Okay. So we find the domain of the function f of x, y, z is equal to this. Similarly, you can find the domain of the so many examples. What we see first? Domain function of three variable. Function of three variable. What we take? Function is f of x, y, z. So we can find the graph of this. So what is graph? Graph of the f of x, y, z. It is equal to what? It is the set of all x, y, z and s, where s is equal to f of x, y, z, and all x, y, z is in domain D. It is in domain D. Now what we can see, this graph goes into the 4 dimension. This graph goes to the 4 dimension, therefore it is very difficult to visualize the graph of the function of 3 variable. Okay. Similarly, what we can find? Level curves. Level curves of f of x, y, z are f of x, y, z is equal to k. F of x, y, z is equal to k. So here is what? Level curves, where here we have to write level surfaces. They are the surfaces, not the curves. Level curves for 2 dimension, 2 variable function, and it is level surfaces for a function of 3 variable. So you can find the graph, you can find the level surfaces. What it means, level surfaces? If you take any example of the level surfaces, suppose there is a one ball which has so many layers, okay, and if you open one by one, then what we are getting? We are getting the spheres. And if you move on this sphere or on this surface, then your point FYZ you have to move, then there is no change of a value of f of xyz, because it is a constant. Okay. Example, find the level surfaces for the function f of xyz. It is equal to f of xyz is equal to x square plus y square plus z square. So what we have to find? We have to find the level surfaces. The level surfaces of f of x, y, z are x square plus y square are f of x, y, z is equal to k. That is what we can take, x square plus y square plus z square, it is equal to k. What it represent? Try to memorize. It is a equation of sphere, which what is represent? Family of a spheres, which is a family of concentric spheres. Concentric means it is center with the same center. Sphere with, what is the radius? Radius is root k. With the radius root k. With radius root k. Okay. So if you take any point, or if you take any level surface, and if you take point x, y, z and you move, it is on the same surface, then it has a same value. This function has a same value. So this is the level surface of the x square plus y square plus z square. Okay. Now we have to discuss the function of n variables. What we discussed before this? Function of 3 variable, 2 variable and also 1 variable. Similar manner, here also a function of n variable is again a rule. It is again a rule that assign each n tuple, means x1, x2 and so on xn. What is it? N tuple. Each n tuple x1, x2, xn to a real number, say f of x1, x2 and so on xn. That is, function of n variable is a rule, z is equal to f of x1, x2 and so on up to the xn. And what is this? This is our n tuple. It is belongs to what? It is belongs to the Rn. And what is Rn? Rn is the set of all n tuples x1, x2 and so on xn, and where all xi belongs to the R and I is equal to 1 to n. Okay. So in the similar manner, what we can say that function is a rule. Function is a rule. Now what we take example? Suppose we have to take example of the function of one variable. Suppose there is a one company. And what company is making of a food item. Okay, food item. Suppose one food item is required. One food item. What it required? It requires n ingredient. N ingredients. Then what? N ingredients. Then suppose what we can take, this is the x1, x2 and so on xi and xn are the quantity of, or x1, x2, xn are the units of units of ingredient use, units of ingredient use, how much unit they are used. And suppose C1, C2 and Ci, Cn, what it represent? This represent the cost of the ith ingredient. And then what we can write? Then total cost of the function. How we find this? Total cost, or it is f of what we can write? x1, x2 and so on, xn. How we find this cost? Cost is C1 x1 plus C2 x2 plus C3 x3 and so on, Cn xn. What we can write? Cn xn. Similarly, what we are getting then? This is our n variable function. That is, this cost or C is a function of n variable. Getting this? What we say? X1, X2, Xn are the ingredients, units, and C1, C2 is the cost, then their total cost is the combination of this. Okay, this x1, x2, xn, we can write it is in the vector form x bar, is it? Then we can write here this and this C1, C2, C3, again this is the second most one vector, C1, C2 and Cn. This is suppose our C vector. Then this function can be written, it is in the form of vector C into x bar. In our book they are given a dark C dot x. Okay, dark means they are showing a vectors, and these vectors are taken from the vector space. They are taken from the vector space. So in short we can write like this also. So similar manner there is what we can say that more than n variable function is also. So n you can take any. So you are getting the so many function. N is equal to 1 variable, n is equal to 2, 3, 4, 5. You are getting the 2 variable function, 3 variable function, 4 variable function and 5 variable function and so on. Okay. So now we discuss our extra problems from this unit or from this topic. So we will go for our 14.1 exercise. I will write first examples and then just I will giving the some fast idea to this. You have to solve it is properly. It is your notebook. Okay. So we will solve some examples from the exercise. Already we solved some examples like this. Just I am giving some idea. You solve it is briefly. So what is first example? Find and sketch the domain of the function f of xy is equal to square root of y minus x square upon 1. Given f of xy is equal to square root of 1 y minus x square upon 1 minus x square. So what we can say that f of xy is not defined, where denominator is non-zero, denominator is 0 and quantity under the square root is negative. So what we can say that is defined, f of xy is defined when 1 minus x square is not equal to 0 and y minus x square it should be greater than or equal to 0. That is what we can say that x square is not equal to 1 and y is greater than or equal to x square. That is x is not equal to plus minus 1 and y should be greater than or equal to x square. And what we can write domain, it is the set of all xy such that what x is not equal to plus minus 1 and y is greater than or equal to x square. Okay, so what we can say, how we draw the diagram or domain, how we draw the domain of this domain, how we draw, this is nothing but our what, y this is our parabola, y is equal to x square, and it is always greater, so this will be there. And what we have to exclude? We have to exclude the lines x is equal to plus 1 and x is equal to 1 and x is equal to minus 1. These two we have to exclude. So this is our domain of the first function. Getting this? So similarly we have to solve the second example. Sketch the graph and level curves. Sketch the graph and level curves. So what we have to solve? Second example, f of xy is equal to given is y square plus 1. We have to draw the graph. The graph is f of xy is equal to z. That is that is what we can write, y square plus 1 is equal to z. Okay. So what we are getting? That means z is equal to y square plus 1. What is it? This represent parabolic surface. This represent a parabolic surface. Okay. Similarly, the level curves are what we can say? Level curves. How we draw the level curves? Level curves is equal to what? F of xy is equal to k. That means f of xy is equal to k. That is our f of xy is y square plus 1. It is equal to k. So how we solve this? Y square is equal to k minus 1. That means y is equal to what? Plus minus square root of k minus 1. So put k is equal to 1, k is equal to 1, k is equal to 2, k is equal to 3, and we are getting so many curves. So k is equal to 1, y is equal to 0, k is equal to 2. Then what should be this? This should be 2 minus 1, it should be plus minus 1. Then what we are getting? K is equal to 3. K is equal to 3. Then what we are getting? 3 minus, it is should be plus minus root 2. So how we draw the graph? This graph should be like this. Okay. This is our x-axis. Okay. Okay. So what should be this? This is y is k is equal to 1. This is k is equal to 2. Okay. So k is equal to, this should be k is equal to 3. K is equal to 4. Okay. So these are the some level curves we draw. Similarly we can draw so many level curves of the function. So what is next example? Next example, draw the level curves of the following functions. Draw the level curves of the following functions. I am giving just one, I will solve just one example. You have to solve it is for homework, second one. So f of xy. So what we can say? F of xy, level curves, it is equal to k. That means what? Level curves. Third example we are solving. So y is equal to, y e raised to x is equal to our k. So what should be y? Y is equal to k upon e raised to x, and that means y is equal to k e raised to minus x. So put k is equal to 1, k is equal to 2, 3, 4, 5. You get the level curves. So what is e raised to minus x graph? What can you draw there? E raised to minus x, this. So you can get the level curves like this. You can get the level curves like this. So this is, suppose k is equal to 1, this is k is equal to 2, k is equal to 3, k is equal to 4. So similarly you can take so many level curves of this. So if you take k is equal to minus 1, minus 2, minus 3, then you can get the level curves like this. Okay, k is equal to minus 1, k is equal to minus 2, k is equal to minus 3. Okay. So similarly you can draw the level curves of the this function also, okay, and this function also. So what is next? Describe the level surfaces of the function. So level surfaces, they are the just the equations f of x, y, z is equal to k. So if you solve the fourth example, fourth one, f level surfaces f of x, y, z is equal to what? K. And then what we can write? This is nothing but x plus 3y plus 5 x plus 3y plus 5z. It should be z. It is equal to what? K. And what it represents? Family of parallel planes. Family of parallel planes. This represent a family of parallel planes. Family because k, value of k, 1, 2, 3, 4, 5, 6, you get the so many surfaces or planes. Okay. So first is our this first surface is our parallel planes. Second one, similarly you can solve. Second, so what should be this? Y square plus z square. It is equal to what? Y square plus z square is greater than k. K must be greater than 0. This represent the family of circular cylinder. Family of circular cylinder with the axis x axis. Okay. So solve all this problem. So thank you very much.